So let's actually run this again now and just see what actually happens. So when it runs, we get actually nothing printed, and that's because there's no finally block to put a print statement in. And it was only printing messages to show that the blocks were being executed anyway, so you wouldn't ordinarily do that anyway. Now you could still add a finally block if that's what you wanted to do, but don't try and close the resources in it because that's unnecessary, and closing some resources when they're not open can actually cause an error. So you leave it to the try with resources block to actually do that for you automatically. So now you can see that what we've got here is, and I'll just close down the run window, it's a lot tidier and a lot more concise. We've only got a few lines of code there, including the try. So it's much tidier, and now that we've done that, let's add some code to also write out the exits for each location. Now using the try with resources form of the try block actually allows more than one resource to be specified, and as a result we can actually create a second file writer to write the exits data out. Now as the code already loops through the locations, what I'm going to do is add an inner loop to write the exits for each location, rather than having two separate blocks of code. So let's go ahead and make those changes. So the first thing we need to do is add a second file writer object in our initial try. And the way we do that is we actually put a semicolon on the first one. We go to a new line, and I come back and put file writer. We'll call this one dir file equals new file writer, and of course that's directions, well I say of course, but directions.txt, and then we'll just move the line back up. So that's how we actually put two file writer objects in the initial try with resources section. Then what we're going to do after the initial write of the location, we're going to cycle through all the directions or the exits for this location and actually write those out. So we can do that with a for loop. So for string direction, it'll be location dot get exits dot keyset. Then we need to write it out. So it's going to be dir file dot write, and it's going to be location dot get location ID, because of course we need the location first, plus a comma, plus the direction, plus location dot get exits dot get, and it's going to be actually direction and plus a new line character, like so. So basically the location data has been written first, and then we're doing a for loop for that location and going through all the exits for that given location and actually saving those to the file as well, which of course is the directions.txt file. So let's actually run that now and see if it works. On the left hand side you may have seen the directions.txt file getting created, so there it is there. And there's our various directions, and it looks like there is something that we need to fix there. We go back to our code and just have a look at that again. And actually there is something I need to change. What I need to do is I need to put another comma there. So just looking at that code, we really need to differentiate that and put the, we've got the original location, and then we've got the direction, and then which exit, which location it leads to, and I didn't put a comma there, so that's going to lead to problems later. So I would put another comma in there, and that would make it be correct this time, and also be a bit easier to read. So we have a look at the directions.txt file now. You can see we've got commas between them, so that's good. So that's all working. So that's a simple way to write data out to a file. Now I should point out at this point that from a purely I/O point of view, there's probably better ways to store the data for this game. So writing it out to a text file like this, really isn't very efficient. But with that said, there can be advantages to storing data in a human readable format like this, and that's because we can edit the data files directly if we wanted to. Like for example, to add new locations and exits would be quite easy by just opening this up in any text editor and making those changes. So at this point, I'm now going to switch over to looking at reading data. So we've created the data files from the game needs, and it's now time to use them to initialize the game's locations. Now I'm going to start by commenting out the code that's currently in our static initialization block. So I'm going to open that up, close down to directions.txt. So I'm in locations, and what we need to do is make some changes now to the static initialization block. So this is the code that we actually placed in here a few videos ago. So what I'm going to start by doing is I'm going to comment out all this code that's currently in here, and then we're going to ultimately see if we can actually read this data back in from these files that we've created. So let's comment all that code out in the static initialization block. into there. So I'll comment that out. We'll go back up to the top again and we'll start adding some code. So we're going to use file reader objects to get data from the two input streams, namely the locations and the directions text files that we've now created. And the process is very similar to what we've just done when we've written out the data, just the other way around. So the main difference is that we need to parse the data into the individual strings and integers. So we're going to use the familiar scanner to do that for us. Now, so that you can see how it's done before Java 7, I'm going to start once again by using try finally, and then ultimately we're going to convert the code to using the new try with resources method. So let's do it the long way first. So I'm going to start with scanner. So scanner equals null. Remember, we need to create this outside of our try block in order to be able to use it in the finally or catch it somehow in the the catch part of the try block. And let's start with a try. And I'm going to catch IO exception E, and we'll just put an e.print stack trace in there for now. And then we'll do finally if scanner is not equal to null, scanner.close. We're obviously getting an error at the moment because we haven't given the try block anything that it can possibly throw an IO exception. So let's change that now. So I'm going to put scanner equals new scanner. And within there we're going to put new file reader locations.txt. Okay, and accept that import. And it's going to be scanner dot use delimiter. You can probably guess what this is going to do. This is a way to tell the scanner that our information is separated by a comma. So the key pieces of information, location, etc., or the description of the location or whatever it is, the actual fields are separated by a comma. Then we put a new loop, a while loop, I should say. While scanner dot has next line. Essentially, we're going to keep looping while we've got some data. We're going to start by retrieving the data now. So int location equals scanner dot next int. So obviously the first bit of information was the location. So we're going to retrieve that into an integer because of course it was an integer. Next we're going to do something you haven't seen before. Scanner dot skip scanner dot delimiter. So you can probably guess what that's going to do. That's now going to skip over the comma to move to the next section. And again, just very quickly, locations.text, you can see we've got the location, we've got a comma, then we've got the description. So we've basically retrieved the location. We've now moved past the comma, which was the delimiter, and we now can continue on to the actual description. And the way we do that, we just put string description is equal to scanner.next line. Next line to retrieve it up to and including the end of line. And if we want to, we can just print that out. We could print out something like imported lock plus another colon. Let's just put another colon on the end there, plus description. Just so we can see that it is importing it correctly. You wouldn't normally put that in your code. For testing purposes, that's fine. And let's now create a locations object from it. So it's going to be map string integer temp exit equals new hash map. Then we're going to put locations dot put. We're going to put lock and then new locations, or new location I should say, which is lock description and temp exit. But for now, you can see that we've actually read in some of this information. So basically the code looks very familiar, and it's very much along the same lines as writing data to an output stream, as you can see there if you remember from a few videos ago. But of course, instead of a file writer object, we're using a file reader, and we're passing it the name of the file as its constructor, and that's the file that's going to ultimately get the data from. The file reader stream is then passed to the constructor of a scanner, causing the scanner to work with the data in the stream itself rather than system.in, which you've seen previously in the course, to read from the keyboard. So obviously it's a different stream. Those The scanner still operates the same in that it's retrieving data, but we've said this time grab it from a file instead of the keyboard. Now I could have declared a new file reader object variable and passed that to the scanner, but you'll actually find constructors chained together like this a lot when performing I/O operations in Java. And in actual fact, the classes are designed to work together in this fashion. So creating a new file reader object like this instead of actually creating a separate variable and passing the variable. Now to see an example of how they're actually designed to slot together, well actually I'm not going to tell you that right away because that's going to make a very good mini challenge. So here's your little mini challenge. Why is the file reader object not closed, despite me saying that closing streams are very important? And a hint here is to remember that you can view the source code for Java objects and methods by control or command clicking on the method. Now see if you can figure that out and come back when you're ready, and we'll go through and solve this little mini challenge. We'll see you when you get back. Pause the video now. Okay, so hopefully you figured out what's going on, or the reason why the file reader object's not closed, despite me saying earlier that closing streams is very important. Well, the reason is that when the scanner is closed, its close method also takes care of closing any stream that it was using, provided that the stream object implements the closeable interface, and the file reader does do that. So I shouldn't really have used the term stream here. It's probably more accurate to refer to it as a readable, because the source for a scanner must be an object that implements the readable interface. So if we actually have a look at this, we're going to look at the scanner's close method. So let's go into the scanner, click on that. Now if we have a look at its close method, let's do a search for close, and you can see that it tests for the source, whether it's an instance of closeable. You can see that on line 1091, and if it is, it automatically calls the source's close method if it is. So consequently, we don't need to worry about closing this file reader object because it's automatically handled by the scanner class itself when it's being closed down. And if we go back to the code, and we're calling scanner.close on line 61, as you can see there. So it's pretty cool how that's handled automatically for us. So remember that a class can implement more than one interface, so an object can be an instance of a closable and a runnable at the same time, and that's sort of really, really important there. So reading the directions text file to build up the exits for the location is very similar to reading the locations, but I'm actually going to do something slightly different there and introduce a buffered reader. So let's look at doing that in the next video.